Okay, now this is actually one of the proofs, the one we're looking at right now, fairly complicated. Okay, it is called the proportion theorem. And as I say, it's fairly complicated, and it counts about 7 marks in an exam. It is one of the 3 theorems that will probably be in your exam. So studying this, you've got a 30%, 33% chance of getting at least 7 marks. So I say it's complicated. It's not really that difficult. It's just much more complicated than what we've done so far. What we've done so far has been very easy. Okay, the proportion theorem says if a line is drawn parallel to a side of a triangle, it divides the other 2 sides proportionally. I don't think that sounds as complicated as it actually is. Okay, I think if I show you what we mean by it, you're going to be a little bit more intimidated. Okay, so there's my triangle. Draw it fairly big. Let's call it A, B, C. If I draw another side, a line that is parallel to, so that's what we say here. A line is drawn parallel to a side of a triangle. So I'm drawing this one. Let's call it DF or DE, parallel to BC. It divides the other 2 sides proportionally. Okay. What that means is that this side here, the 2 sides remaining, AB and AC, is now divided. It's now divided into AD and DB and into AE and EC. What we mean by proportionally means that they are in proportion. In other words, if I were to take AD, the length AD, and I divide it with length BD, I would get the same answer as if I take line AE and I divide it with EC. In other words, if I take this top divided by that, it would give me the same answer as this divided by that. Now, proportion is all about having the same fraction. So for example, if I have a head and a body and arms, okay, I don't know if this is true, but if I wanted to draw something in proportion to this, okay, you'll see that the body is about twice the size of the head. So to draw something in proportion is if I double the head, I have to double the body. So if I kept the body the same, okay, would you now see that the 2 pictures are out of proportion? If you see someone whose head is twice your head size, but the body is the same size, you're going to think the guy looks a bit weird. Alien, maybe. Okay. So in other words, proportion means that ratio, the size of the one compared to the size of the other, is the same. Then it's in proportion. And that's why the size of this one compared to that one is equal than the size of this one compared to that one. Does that make sense? You understand the theorem? Okay, now the proof. Okay, good luck. Okay, for this proof, I'm just going to redraw the sketch because there's quite a bit of construction. Okay, the first construction, no wait, let me start by A, B, C, D, E. Okay, the first thing I'm going to do is I'm going to start with my what? My to prove. To prove, I'm going to prove that AD divided by DB is equal to AE divided by EC. Okay. Now, in order to do that, here comes quite a list of constructions. The first thing I'm going to do is I'm going to construct a line perpendicular from D, perpendicular to AE, and also from E perpendicular to AD. Okay, so what I'm going to do, and maybe it's going to help for me to give you the broad picture, I'm going to get two different ways of finding the area of ADE, triangle ADE. And I'm first going to use this one as a base, and then I'm going to use that one as a base. So to do that, I need two perpendicular heights. Can you see that? I don't know if I can rotate with this program. Let's see. Doesn't look like it, but so turn your head so you can see this here as your base, and then you see there's the perpendicular height. Okay, so remember, the perpendicular height is how high is the other vertex, is the vertex above this one, and then turn your head this way to see it's the same triangle, but I'm just using a different base. Okay, and I'll call the one H1 and the other one H2. Okay, that's the one thing, and then the other thing I'm going to do is I'm going to draw another construction here. Okay, I'm going to create a triangle DBE and a triangle DEC. So I'm creating this triangle. I'll color it in for now. I'm creating that triangle, and I'm creating this triangle here. Can you see those two triangles? Okay, this one here and one here. Do you notice it? You see both of those triangles share a base, DE, and both of those triangles they are triangles between two parallel lines. That means that those two triangles have the same area. So I'm also going to show, that's the second step, I'm going to show that area area of triangle DEB is equal to area of triangle ECB. Okay, I'm going to show those to have same areas. And from these two formulas that I'm going to get, I'm going to get two equations, and I'm just going to solve them simultaneously, or not really solve simultaneously, I'll combine them. and from that combination I will get this. Okay, so that's the overview of what I'm going to do. So even though it seems complicated, it's really actually simple. It's just doing two things and they just take a few steps. So for example, the first one that we said is we're going to find two different ways of expressing the area of triangle ADE. Okay, so I'm going to do my construction. It's not really important how you phrase your construction, as long as the person reading understands. So I'm going to say construct H1 the perpendicular, let's write it like this, the perpendicular height of triangle ADE on base AD. Okay, and actually before we go into all the constructions, what I think will make it easy is if we do the construction and actually then do a statement. So we're going to say area of triangle ADE is equal to half the base, but now I'm using base AD, half AD times H1, which we said was the perpendicular height. So E is, this height is H1. Does that make sense so far? Guys, you need to stop me if it doesn't. Carl? Yeah. Are you sure? Bravo, you sure? Okay, cool. That was the first construction. Now I'm doing another construction. Okay, another construction. This time I'm constructing H2, which is the perpendicular height. Now I'm just turning this top triangle a little bit. Now AE is my base. So it's the perpendicular height of the same triangle, of triangle ADE, but this time on base AE. Make sense? So I draw in, that's the perpendicular height on AE. Turn your head, it should make sense. So now we have that the area of triangle ADE is equal to a half, and this time my base is AE and my perpendicular height is H2. Okay, and guys, you'll see that I am calculating the area for the same thing, which means that this answer and this answer must be equal. In other words, a half of AD times H1 must equal a half AE of H2. Does that make sense? So far it's not difficult. Good. It's just a lot of stuff. Okay, the next thing I'm going to do is I'm going to make this construction, BE. So leave this one right here, we're going to use it later. Okay, put it in the fridge, okay, to cool down. And let's bring the next one to a boil. So the next construction, construct, now simple construct BE. Construct BE. That's just the line that wasn't there before. Now we have a triangle DBE. Okay. And also construct DC. So now we have a triangle DBE and EDC. Okay, and you'll notice now if this is the base, okay, so the area And this one might be slightly more complicated. The area of triangle DEB, so I'm working that area DEE is, and I'm using the base DB. Why am I using DB? Because of what I want to prove. I want BD to be part of my formula, and that is why I used AD as the base here, because I want it as part of my formula. You see that? Okay, so the area of triangle DEB is a half DB that I'm using as a base. Now I wonder if you can see from here, if DB is my base, what is the perpendicular height of E above this base? I have to turn your head. You are saying it's ED. DE, this is not 90 degrees. I really don't think I can rotate using this program. Okay, but that would be very helpful if I could. Okay, so now you can see that H1 is the perpendicular height that E is above the line DB, or if I just extend DB to A, you can see that. Okay, so if I wanted to get the perpendicular height for this one, it would then be H2. Now the same goes for the area of triangle DEC. I go back to show you DEC. So there's DEC. If EC is my base, EC is my base, turn your head to see that this is the perpendicular height that D is above this base. You see it? Good. So that no, the first one is H2 because there's. Oh, you are right. Sorry. Okay. So this one is H1. Thank you for correcting me. This one is now the base. What was the base? EC. Base is EC, and the perpendicular height is H2. And this is from definition. Like we've made a bunch of statements. We should just say from def. That's just area of a triangle. If we had to give a reason why this is equal, it's from the definition. Okay, so this is also from definition, from definition. Okay, try to give as much reasons as you can. Okay, so now we are going to say that the area of triangle DEB is equal to the area of triangle DEC. Not because they have the same formula. Let's go back. Why are these two triangles, why do they have the same area? Same base, same height, but we've proven that theorem already. It's triangles between parallel lines. You can use that as a reason. So triangles between parallel lines. We know that the area of triangles between parallel lines are equal, and for that same reason, they're sharing the same base and they have the same perpendicular height. But that then means that these two sides are also equal. In other words, therefore, a half dB times H1 is equal to a half EC times H2. And here I've now brought to boil equation 2. And now I'm just going to mix the two. Okay? And I do that by saying, let's now remember what we want. We want AD divided by DB. So, in our first equation, that's AD and that's DB. And if I divide the two, all the rest will cancel. You see? So equation 1 divided by equation 2 will give me a half AD times H1 divided by a half DB times H1 is equal to, on the other side, I have a half AE H2 divided by a half EC H2. And here H1s cancel, halves cancel, H2 cancel, so that I have my conclusion that AD over DB is equal to AE over EC.